Welcome, class, to the Intro to Java Programming. This is the second of 3 lessons on looping statements. In this lesson, we will review the enhanced for loop along with the visual example, the syntax, and some code examples. Let's start with a string array called my children and populate with a few names. If we wanted to output each name, these 3 lines will work. Can someone tell me a better way to output each name from the array on a separate line? Correct. Often you will be in a situation where you need to execute a set of code multiple times until a specific condition is met. There are 4 types of looping statements that will accomplish this task. In Lesson 24, we talked about the standard for loop. This loop is used when you know the exact number of iterations a block of code will be executed. In this lesson, we'll cover the enhanced for loop, often called a for each loop. The enhanced for loop is used to iterate over each element of a collection. Let me show you with the previous string array example. Let's remove these 3 output lines for now. We need to add the shell of our for loop statement. Here is the for keyword. There are parentheses to hold the components for the for statement and curly braces to hold the code block to be executed. We only need 2 components inside the parentheses. Let me ask, what variable is the collection to be iterated over? Correct, the variable name my children. The collection variable is the second component and goes here. Next, we need to know the data type of this collection and create a temporary local variable used by the for loop. So, what is the data type of the collection to be used by the for loop? Yes, the my children array is an array of strings. Here is the data type string with the variable name child. The variable used can be any name you choose. Since our collection is called children, a single element could be called a child. Item is another common variable name to represent one item from a collection of items. Place a colon between the components as a separator. Let's add the systemoutPrintln method with child in parentheses. This for loop will output each string value from the my children array. The enhanced for loop may look confusing at first, but let's try to clarify this example. I will use 3 students to represent the 3 children in the array collection. Here is a variable my children with our 3 students. Here is a variable called child that will represent the current element of the collection. Now let me show the flowchart as we process all the children in this for loop. The for loop is started. The purpose of the loop is to process each element of the collection, being that the code block will be executed for each element. Get it? For each element. It is often referred to as a for each statement. Other languages like C# use the for each command. Coach Joe Rule 33 states, use the enhanced for loop when iterating through a collection. In the flowchart, a decision is made to determine if there are any elements remaining in the collection. If there is an element, it is assigned to the local variable child. This child is the element that will be used inside the code block. The code block is then executed. The println method is called and Virginia's name is outputted. After the code block is completed, the decision process happens again. There is another child, Barb. The code block is executed. The println method will output Barb's name. The decision process happens again. There is another child, Aaron. The code block is executed. The println method will output Aaron's name. The decision process happens again. There are no more children in this collection. The code will exit the for loop and proceed to the next statement. The break and continue commands are allowed inside the enhanced for loop. Even though these commands are allowed, you should limit their use. Let's cover the break command. During the execution of the code block, you may decide the loop should end. The break command will stop the loop. There are situations when a break is a valid exit option. The other command is continue. During the execution of the code block, you may decide to stop processing code for this iteration of the loop. The continue command will exit the code block and the decision statement is called again. If there are more elements in the collection, the code block will be called again. The continue statement does allow code block execution options. However, it's an indication of poorly designed code. Without going into too many details now, the continue statement violates many Coach Joe rules that will be covered in future lessons. For now, see if you can find a way to avoid this statement. Let's go to our basics project in IntelliJ, close any open class tabs. Let's navigate to the test Java loops package. Create that if you need to. And let's create a new class called forEachTest. Let's make a little space. Copy in this first test. Import these classes. This first test will output the values of a string array using a for loop. A string array of my children is defined and populated. Here is an enhanced for loop. My children is the collection to iterate over. String child is the local variable that holds a single element for the code block. The print line method will output the child's name. Let's run this test to see the output. All three children appear in the output. This test will show a break statement inside the for loop. This is the same test as the previous test with a small change. Inside the for loop is an if statement. If the child's name contains the lowercase letter s, a break statement will be called and the loop will exit. The second name contains a lowercase s, so only one name should appear in the output. Let's run this test. Only one name appears in the output. This test will show a continue statement inside the for loop. This is the same test as the previous test with a small change. If the child's name contains a lowercase s, a continue statement will be called and the print line method will not be called for that child. Only one child's name contains a lowercase s, so two names should appear. Let's run this test. Two names appear. None of them contain a lowercase s. This test will iterate over each character in a string. We define a string collection and item count variable. Here is the for loop. String collection is turned into a character array. Item will hold a single character. Inside the loop, item count is incremented by 1 and print line is called with the single character. There are 10 letters in this string variable. The assert expects item count to be 10. If we run this test, it passes. This test will iterate over each element of an array. We define an array of ints and an item count variable. The int array is the collection that will be iterated over. Int item is the single element from the array. If we run this test, it passes. This test will iterate over each object in an array list. This private method will be used to create the array list. In lesson 15, we created the payRequest object. Here's the payRequest object code. Back in the test, we create an array list that holds the payRequest objects. Here, a payroll service object is created. Again, from lesson 15, we created the payroll service class. Here's the code. The for loop is defined with the payRequest list variable that is an array list collection. PayRequest is the data type of a single element of the collection. Again, the local variable item is used. Inside the loop, an int variable, netPay, is created and holds the result of the .getNetPay method from the payroll service object. The item is passed as a parameter. The print line method will output the netPay value. Let's run this test. And it passes. Notice all the netPay results. It is common to iterate over a list of objects and use the item as a parameter in a method call. This test will iterate over each object in a set. This private method will be used to create the set. We create a variable to hold a set. The build hash set method is called. Here is the collection the for loop will iterate over. Item is the local variable. It is a string. If we run this test, it passes. The final two tests will show a for loop with a map. This test will iterate over the key of a map. Here's a private method that builds the map. The map variable is created and populated with a build hash map method. Here is the collection the for loop will iterate over. Remember, a map has a key and a value. Here the key set method is called, so the loop will iterate over the keys, not the values. The key was defined as an integer, so the local variable item is an integer. If we run this test, it passes. And this test will iterate over the value of a map. The map variable is created and populated with the build hash map method. Here's the collection the for loop will iterate over. The value method is called so the loop will iterate over the values, not the keys. The value is defined as a string, so the local variable item is a string. If we run this test, it passes. Here's a summary of all the test code we wrote for this lesson. Which for loop should you use? Let's talk about a couple of guidelines. The standard for loop should be used when you know exactly how many times you need to execute a block of code. Typically, this situation happens less than 10% of the time. The enhanced for loop is used when you need to iterate over a collection like an array, array list, set, or map. This will be a very common looping situation. Time for a Coach Joe challenge question. Take a look at this for loop statement. Is this the correct for loop to use for this situation? This for loop will work, but it is preferred to use the enhanced for loop. If the standard for loop has a condition that uses a .length or .size method, you're using the wrong for loop. You should now have an understanding of the enhanced for loop, including the syntax and code examples. Use of the enhanced for loop is meant for those situations when you're iterating over a collection object. Your optional homework assignment is to create a test that will use a for loop to add all the int values of an array and verify the sum is correct. In the next lesson, we will discuss the do and while loops. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!